Astronomers claim that they've captured a red supergiant's death throes. They said for the first time he watched a red supergiant star explode. This is by Northwestern University. For the first time ever, astronomers imaged in real time, the dramatic end to a real supergiant's life, watching the massive star's rapid self-destruction and final death throes before collapsing it into a supernova, type 2 supernova. Led by researchers at Northwestern University and University of California, Berkeley, the team observed the red supergiant during its last 130 days, leading up to its deadly detonation. So it happens quickly, as we can see. The discovery defies previous ideas of how red supergiant stars evolve right before exploding. Earlier observations showed that red supergiants were relatively quiescent before their deaths, with no evidence of violent eruptions or luminous emissions. The new observations, though, detected bright radiation from the red supergiant in the final year before exploding. This suggests that at least some of these stars must undergo significant changes in their internal structure, which then results in the tumultuous ejection of gas moments before they collapse. It's a breakthrough in our understanding of what massive stars do moments before they die, said Wynne Jacob Gallan, the study's lead author. He said, direct detection of pre-supernova activity in the red supergiant star has never been observed before in any ordinary type 2 supernova. For the first time, we watched a red supergiant star explode. The discovery was published January 6 at the Astrophysical Journal. Although the work was conducted at Northwestern, where Jacobson Gallan was a National Science Foundation NSF Graduate Research Fellow, he's since moved to UC Berkeley. Northwestern co-authors include Diane Coppinges, Charlie Kilpatrick, and many others. We've never confirmed such violent activity, they said. Finally, support my Patreon account. The daily posts are 5 videos daily, and they are totally different from what I have on my YouTube channel. Thank you so much for your support and that you find all my content so interesting. You'll find the Patreon account details in the description box. The University of Hawaii Institute of Astronomy PAM-STARS on Haleakea, Maui, first detected the doomed massive star in summer of 2020 via the huge amount of light radiating from the red supergiant, and a few months later, in the fall of 2021, a supernova lit the sky. The team quickly captured the powerful flash and obtained the very first spectrum of the energetic explosion, named supernova 220 TIF, SN 220 TIF, using the WM Keck Observatory's low-resolution imaging spectrometer on Mauna Kea, Hawaii. The data showed direct evidence of dense circumstellar material surrounding the star at the time of explosion, like the same gas that PAM-STARS had imaged the red supergiant star violently ejected earlier in the summer. It's like watching a ticking time bomb, said Raffaella Margutti, adjunct associate professor at Sierra and the paper's senior author, saying, we've never confirmed such violent activity in a dying red supergiant star where we see it produce such a luminous emission, then collapse and combust until now. The team continued to monitor SN 220 TIF after the explosion, and based on data obtained from Keck Observatory's Deep Imaging Multi-Object Spectrograph Near-Infrared Echolette Spectrograph, the researchers determined that the SN 220 TIF's progenitor, red supergiant star, located in the NGC 5731 galaxy, it's about 120 million light years from us, was 10 times more massive than the Sun. Remote possibilities. Margutti and Jacobson Gallan conducted most of the study during their time at Northwestern. Northwestern's remote access to Keck Observatory telescopes was integral to their research, and from the University of Evanston campus, astronomers can connect with an on-site telescope operator in Hawaii, and they choose where to position the telescope and bypassing long-distance travel to Hawaii, astronomers have precious observation time, often catching transient events like supernovas, which can quickly flare up and then swiftly vanish. This significant discovery of a red supergiant supernova is yet one more strong indication of the importance of Northwestern's investment in access to top private telescope facilities, including the Keck Observatory. This is what Vicky Calogera of Northwestern College says. The Keck's telescopes, currently the best on our planet, uniquely enable scientists advanced of this caliber, as Sierra's researchers have shown since our Keck partnership started just a few years ago. Margutti and Jacobson Galan and their Northwestern co-authors are members of the Young Supernova Experiment, which uses the Pan-STARRS telescope to catch supernova right after they explode. I am most excited about all of the new unknowns that have been unlocked by this discovery, Jacobson Galan said. Detecting more events like SN 220 TIF will dramatically impact how we define the final moments of stellar evolution, uniting observers and theorists in the quest to solve the mystery on how massive stars spend their final moments of their lives. The study was supported by NASA, the National Science Foundation, the Hastings Simmons Foundation, the Canadian Institute for Advanced Research, and Alfred P. Sloan Foundation and Willem Fonden. This was from Northwestern University on Science Daily. Please leave your comments, and thank you for your support.